Assalamualaikum. Today we will discuss about hydrostatic forces on different kind of surfaces. In the playlist we will discuss about total 4 kind of surfaces where the hydrostatic force works. And in this video we will dive into topic hydrostatic forces on vertical plane surfaces submerged. It means under a any kind of fluid, a vertical plane surface will be submerged under that fluid, and we will find out the hydrostatic force that are working on this plane for the fluid. The surfaces are submerged in a static fluid. Static fluid means it's not moving. As here from the name here, hydrostatic means the fluid will not move, and we'll find the hydrostatic forces for that not moving fluid, static fluid. As this surface is submerged under that fluid, so there are certain forces that are acting on the surfaces. Suppose this is our free surface, suppose it's OP. This is our any kind of free surface, and this is our any vertical plane surface, any kind of object that are submerged under the fluid. It will be in any type of irregular shape, so we just take a random shape, and this is submerged under, suppose it is any kind of fluid, and this surface is submerged under the fluid, and suppose this is our plane free surface. Now what will we do? We will find out the hydrostatic force that work on this surface for the fluid. Let's start. At first, let's see, this is our object, and this point G we denoted as G. This is the centroid of this object, and this P is the center of pressure where all the hydrostatic forces will work. We just assume these points, and here at first we will take a small strip that is dH in height. We'll take a small strip where the hydrostatic force dF will work, and then we will find the entire hydrostatic forces. And the distance between the free surface and our small strip, we denoted it as H. And the distance between the free surface OP and the centroid, we denoted this as H bar. And the distance between the free surface and the center of pressure, we will denote it as H star. This is our H star. And the width of this object will be B, and the height of this object will be AB, and we take a random plane surface. What will be the area of this small strip? The area of this small strip will be dA. Here we use D because this is very small. dA equals to, we know that the area will be width into height. So the width of this small strip is B into the height of this small strip is DH. B into DH. This is the area of this strip. So here what will be the pressure that works upon this small strip? Let's find the pressure on this small strip. That will be rho GH. Because the height from the free surface of the strip is H, so here we'll use H, and we know the formula, which is rho GH. And now we'll find the pressure force that works upon this strip. The pressure force on this strip will be dF, which is pressure into area, but the pressure upon this strip is P strip, and the area of this strip is dA. So the total force will be P strip into dA, which is rho GH into dA. This is the pressure for our this small strip, but here we have to find the total pressure force that works upon our total surface. Now we have to integrate to find out the total force of the entire surface. So now we will integrate this small pressure force to find out the total pressure force. So the force on entire surface will be F equals to integrate of dF. Now we will integrate this small force. It's equals to integration of rho GH dA. This is, and here this rho G is a constant, so this will be out from the integrate sign, rho G, and we will integrate this H and dA. What is the mean of this integrate sign? Means we will include the whole things. Here look at this. Here this H is for just our small strip, but if we want to take the whole object's height, then what will be? We will consider then the centroid. It represents the whole object. So now for integrating this H, we will took the whole height for this entire object. So the height will be h bar because this centroid represents the whole object. So we'll take the height between height difference between the free surface and our centroid, which is h bar. And after integrating this dA, what will be the answer of this integration? If we integrate, the dA is the small area for this small strip, but if we want to whole area of this strip, that will be A. A is the area of this whole strip. So if we integrate this, this will be h bar A. Rho g h bar A. This is our total force. Here we find the total pressure force, but we have to find out this h bar because in the under the h bar distance the total pressure will be works, and we have to find this specific point where our total hydrostatic force will work. So the moment, we will now find out the moment of the force dF about the free surface. At first, let's take the moment of this small strip, which is dm equals to, we know that moment equals to force into shortest distance. This is dF into h. We are finding the moment for this small strip. For this small strip, here the force is dF and the distance between from the free surface is h. So here we use dF into h, and from this we know dF equals to rho g h dA into h equals to rho g h square dA. And as we want the moment for our entire object, now we will integrate this short moment. The moment for this entire strip will be m equals to integration of dm. We will integrate this term, which is equals to c. For the total object, here this is our center of pressure, and here our total force work at this point. So F is the total force of this point, and the height or distance between the free surface and this force is h star. So it's from the equation of moment we can write here F into h star. Now we'll put the value of dm from here. It will be integration of rho g h square dA equals to F into h star. We will find this h star, the value of h star. As the rho g is a constant term, so rho g integration of h square dA, that's equals to F into h star. Here this term is the moment of inertia of the free surface. So we can write, instead of this term is I naught, which is the moment of inertia of the free surface. So it will be rho g I naught equals to F into h star. According to the parallel axis theorem, we know that I naught equals to Ig plus AH bar square. Here this is the moment of inertia about the centroid, moment of inertia of the centroid of the free surface, and this is the moment of inertia of the free surface. So here we'll replace this term instead of I naught, and as we want to find this h bar, we will write h bar in one side and this put this F into that side. So here remain rho g I naught divided by F, and rho g into Ig plus A h bar square. We just replace this term instead of I naught divided by F, and if we put the value of F from this equation, we will write rho g into Ig plus A h bar square divided by F equals to rho g h bar A. Here rho g will be cancelled out and remains this term, which is Ig plus A h bar square divided by h bar into A. This is h star, and if we simplify this term, this will be h bar equals to Ig divided by A h bar plus h bar. This is our required formula of finding the distance between the free surface and the center of pressure. All the hydrostatic force will work.